All right, yeah, welcome back. We are continuing from where we stopped last time. So now we are looking at regression as a part of our um, machine learning. So, but under machine learning, regression, if you remember last time we talked about supervised and unsupervised learning under machine learning. And we talk about supervised learning, we talk about regression and classification. So under regression, we have uh, simple linear regression, we have multiple linear regression, um, and many other regressions that we have. These are the two common ones that we always meet along often in your data analysis. And the regression allows you to actually predict the value of a variable, which we call dependent variable, against on the independent variable, right? Or based on the value of another variable or variables called independent variable. The dependent variable is called y, independent variable is called x. We have y-axis, we have x-axis. So we are trying to look for if there's any association or relationship between the two variables. What happens to variable y when x changes? We are trying to predict the value of y, or otherwise called dependent variable, when the predictors or x-axis changes. All right. So there's not much difference between simple linear regression and multiple linear regression. The only difference is numbers of the predictors, which is x-axis. That's all. That's all. That's only the difference. I'm going to show you an example just now. I'll give you an example because when you have multiple x-axis combined together, then it becomes multiple linear regression. But when you just have only single predictor, which is x-axis, it is called simple linear regression. So that's the only thing. That's just one-to-one. That's what it means. All right. So we are going to use this particular data set called marketing. So we run the marketing here. Okay, just run this line. All right. So it's already in my data. I will attach this data set as well for you to use, so you can glimpse it and see what is inside. So if you glimpse it, we have YouTube advertisement, we have Facebook, we have newspaper, and we have sales. This phase is a continuous variable. All right. So this is based on amount we generate when we use each of these particular advertisement. So when we advertise, we spend this amount on YouTube, we spend this amount on YouTube, we spend this amount on the newspaper, on Facebook and newspaper. How much is the sales we generate? That is it. So which one gives us more yield or profit? All right. So that's what I was looking. So this is just a glimpse of the data. We have basically four variables, and we have 200 rows or observations. All right. So you can summarize to see the structure of the data. Okay, mean, mode, and median as usual. Okay, you have understood this. It doesn't have any what do you call it now? Any missing value. All right, so you can investigate further, but we don't have time for that for now, so you can do that later. And let's look at the first few rows. The few rows we have YouTube, Facebook, newspaper, and the sales. All right, so now what you want to do now, you want to first build a model. The first model, we will build a simple linear model to predict sales units based on the advertising budget spent on YouTube. Okay, we want to look at one first. This is called one-to-one, which is called simple linear regression. Regression equation can be written as follows. We have sales equals to b naught, which is our constant, plus the intercept times YouTube. Okay, so we run this. We call it. You can call it any name you want to call it, but I want to call it model one. Our new object model one. So we use LM function, linear model function. Okay, we pass our sales as y. This is y-axis. Our sales will be in y-axis, which is our continuous variable. All right. Then we pass our YouTube s-axis. This s-axis now. Okay, which is called predictor, right? Or independent variable. It's called dependent variable, independent variable. Okay, we have only one for now, so we use the one we have for now. So our data is about marketing, right? We run this line, all right. We now summarize. We run the summary here, all right. So it will give us our result, all right. So first of all, from the result you can see We have a general p-value, which is significant for all of them. All right. We have a multiple R square, which is 0.6, it means 61.9192%. And then when it's adjusted, but this should be Bonferroni adjustment. We have something not much difference, so 61 also percent. All right. Now this is our estimate. We have a residual here, okay, and then we have our coefficient, which is very important here. So we have our estimate of each of the individual units here. We have our standard error, we have t-value, and we have our p-value. So for this YouTube now, it is highly significant, which means there is a linear relationship between the predictor and the our continuous variable, which is called sales. So it means that they are perfectly correlated. That's what it means. So it means that any amount spent on YouTube can yield, okay. So there's association or relationship between significant association or relationship between YouTube and sales. That's what it means, right? That's why we have a very significant this thing here. You can see, so it's less than 0.01, 0.05 rather. So this is it here. Now prediction can be easily made using the R function predict. In the following example, we predict sales unit for 2 YouTube advertising budget. For example, if you have 2 units of 0 and 100, you can predict the sales. You can say new data, a new object is created now. We pass our data frame, call it YouTube equals to, it pass 0, 1000 units, for example, 0 units, 1000 units. So when there is 0 units, how much can we generate? 1000 units, how much can we generate? So if we do that, we can run this line. All right. We're trying to pass this one to say YouTube. When YouTube is 0, when YouTube is 1. That's what I'm trying to do now. How much sales can we get? That's what I'm trying to do. So we create a new model, call it model 1. We call our model 1, which already run before. We predict it using a piping. We pipe it here. All right. We now run this line. All right. So what we got, we got this for 0 units. Right. This for 1000 units of YouTube. All right. So if you check very well our result, what we got here, you see that we got the same answer here for this intercept here. All right. So the same thing we get for intercept here, 8 point. So this one basically for 0 units now. So it means that for this it's talking about 0 unit of YouTube. That's what we got here. All right. So but if we now have which is this thing, same thing. But if you now have 1000 units, we get what we get is this. Okay, that's our estimate. Okay, this is our estimate. If you are dealing with a 1000 units of YouTube advertisement, we have this estimate of sales. So this is what we change to this one now. This value it just was 0 units. All right. So and it's still significant as well. So that is how you measure your predictors together with a dependent variable. So that is just for one-to-one, which we call it a simple linear regression. So that is there's a linear significant relationship between the between YouTube and sales. All right. So increasing the value of YouTube means that automatically increase the value of sales. That's what it means. All right. When the value of the advertisements increases based on YouTube, it simply means the value of sales or profit increases. All right. So let's go further to multiple linear regression now. So now we want to use the same method now to build a model for estimating sales based on the advertising budget invested in YouTube, Facebook, and newspaper as follows. So we have our sales to our constant B naught. Okay, we have our slope. You have YouTube, you have Facebook, you have newspaper. This is how the equation is. Okay, our linear equation. All right, so we call it model 2 now. This is model 2. So we use our linear model LM, our axis, y-axis. Now you pass YouTube plus Facebook. Let's say plus newspaper. First, let's see newspaper. All right, so we have 3. So if you run this model, all right, our data is still in marketing. So don't forget, run this model. We summarize the model. You have the summary. So let's see, it's highly significant, which means 1 or 2 model in this particular one or two parameter in this particular model is significant. One or two variable is significant. That's what it means. So we don't forget our general p-value is highly significant, which means one or two of the variable parts is significant. Our f statistic is very high. Okay, our degree of freedom is df, and then you can see our error 2.01 on 196 degree of freedom. So our R square is see 89%. Also, when it is adjusted, nothing changes much. So, all right, so if you look at our estimate here for YouTube, you see it remain intact, but this has changed because we have passed multiple values now. Now we have a significant value for YouTube, we have for Facebook, but for the newspaper, it's not significant. In fact, the estimate is negative. Okay, it's downward slope. That means a downward slope. All right, you can see T value also is negative here. All right, we show that it's a downward slope. Now, this is telling us that the budget spent on newspaper is not really significant with the sales. That's what it means. It means newspaper advertisement does not yield good sales. Okay, it means that if spending money on newspaper does not help the company. So we can drop this particular line, which is newspaper. We can drop because it's not helping the company at all. So it means that it's not generating sales even when we spend money on newspaper. That's what it means. So we don't need to waste money on newspaper by spending money. So we can remove newspaper because it's not generating much sales. So which means it's not helping the company. We can remove this. All right, so we can save now. So we can do with this only these two. If you run this line again, right, we run this again, so we can see the changes. So we have YouTube and Facebook only now, which show that both YouTube and Facebook, they are highly significant, which means both of them yield high sales when the advertisement is invested on them. All right, so they bring about high sales. So we can finally have our model written as follows: sales equals to 3 plus 3.5. Now this is our estimate now intercept 3.5 plus our slope here 0.45. That's what we got. Okay, and then times YouTube, the unit of the YouTube, then 0.18. Okay, or say we can operate to 19 if we want 188 other for Facebook. And we have dropped for in newspaper. That's why we cannot continue with that. So we can see that this is what we get normally under normal circumstances for our formula. All right. So we can test and plot the model and see how it look like for sales against YouTube or Facebook. And if you run this line of code, for example, on our model 2, all right, this is what we have. All right, this is what we have. All right. You can see that the slope is not that getting much, but if you change it to YouTube, let's see, to YouTube, this will probably have higher sales. I mean higher relationship with the model. All right, you can see some one here there, so you can see it's higher. All right, YouTube is higher, more related with sales. You can see that it has a more perfect linear relationship. All right, so that is how we got it. This one. So for a YouTube advertisement budget equal to 0, we can expect a sales of 8.38 units. That's what it means. We will see from here. All right, from here, can expect so for a YouTube advertisement budget equal to 1,000, we can expect a sales up to 8.3 times plus. All right, so this means we can expect this will be 8 point. This is not 8.9. This is 3.5. 3.5. All right, units for YouTube. So for YouTube is sales. We can at 1,000 we can expect 3.5. So this 3.5 here plus here we have 0.45, 0.46 approximately times 1,000. Okay, So this for 0 units. So this for 1000 units now. So plus this we have 55 units. All right. So this is what we got. If it increases like we did the other time, we go for 55, but which not here. So if it increases to 1000 units, so that is a it means that both YouTube and Facebook will bring yield. All right, will bring high sales when money is invested on their advertisement for both. So far, what you have dealt with is actually called linear relationship between two variables, between y-axis and x-axis, which means that there's an association or relationship between the two dimensions. But we can also further investigate if we do regression actually means that it looks at a relationship between the two dimension, which is a y-axis and x-axis. But at the same time, we can still investigate further any interaction between the x-axis S component, which means the predictors x-axis. Is there any interaction? Because regression does not stop on relationship, it also goes further to look at what is called interaction. Is there any interaction between x-axis and y-axis? I mean, between two x-axis rather. So, for example, now all we have done so far is looking for the significant relationship association between dependent and independent variable and independent variable or variables. All right. Meanwhile, we can also find if there is any significant interaction between the independent variables we have used so far. We have which are our x-axis. So we have YouTube, we have Facebook, newspaper. So we can also look at if there's any interaction between them. Is there any significant interaction between them? Do they interact significantly? So we can do that by changing our plus here to times. So if we call the model 3, for example, model 3, all right, we take our sales, all right, YouTube times Facebook. What we are trying to do is that we want to look at the interaction between YouTube and Facebook. Do they interact? There's any interaction between two of them? When you are running YouTube at the same time on Facebook, do there any interaction between them to bring about sales? All right. So there are several reasons for this. Okay, you may want to check interaction between two variables. Okay, two variables to see if they actually interact to bring about the result we got in y-axis. All right. So if you run this line now, you summarize our model 3, all right, we get a value here, already significant as well, all right, which means that the ratio between one or two variables. But when we check here properly, you see YouTube here, okay, is significant, and Facebook you see what significant. But even though YouTube is see highly significant at this time now, okay, why Facebook is a little bit come down. But the last line here is called interaction line, all right, between YouTube and Facebook. All right, they are significant, which means that there's a significant interaction between Facebook and YouTube to bring about the sales, which means they communicate together. Okay, as you are running YouTube or Facebook, there's a communication between YouTube and Facebook, all right, to bring about the sales. So this is called interaction between the predictors or between the x-axis, or otherwise called independent variables. So this is can be done at any time. You can also run ggplot to bring about to look for to try to print a better plot than the one we have done so far. So let's run this line and see how we can generate a better plot. So this is our new plot. Okay. So this one for YouTube marketing sales. All right. So you can see the regression line here. All right. So you might want to further investigate maybe later to look at the correlation between two of them. Okay, that may be needed, but you can see that YouTube is more correlated than the Facebook. All right. So, but we don't need to spend much time on that for now. Right. That is just correlation, just a call.test. All right. You can find the call.test in bracket says YouTube. Then you do that again for says Facebook and see the difference between the correlation. Then you can. So this is what we have done so far today under this simple and multiple linear regression. So you can go further to use your own data set also to predict and see what how both of them work. So I will see us again in the next section, the next class. Thank you so much for listening. Goodbye for now.